Okay, so now we are going to review questions 1 through 10. It's going to be really repetitive. I'm sorry for those of you who know what you're doing, but I think it's necessary, and I hope by the end of the video that most of you will have a really solid idea of what you're doing. So sometimes repetition is good, even though it's boring, because it helps us learn stuff. Okay. So below is a representation of the Earth-Moon system. We want to draw a schema. So we'll start with that. And we only have 2 objects. So we have the Earth and we have the Moon. And we're going to connect them. There's only one interaction. They're not touching, and it's actually weight, or no, it's weird to think of the weight of the Moon. So we'll call it gravity. And so we want to draw a free body diagram for the Earth. So a trick to drawing free body diagrams is we are going to draw kind of a boundary around the Earth. There's only one interaction, so we can only have one arrow on our free body diagram, okay? Only one arrow per interaction. There's only one interaction. So we're doing... we need to worry about the direction. So I'm going to write out my label first. So we're going to look at the force on the Earth by the Moon. The Moon is attracting the Earth. So my dot is the Earth. It's got to be a dot. Some people are drawing huge circles. It's not a circle. It's a dot for a free body diagram. And the Moon is pulling the Earth this way. Okay. So that is what it should look like. And then, is there a normal force in this scenario? So number 3, no normal force, because the objects are not touching. No normal force because the objects are not touching. Okay, so let's see what you guys have done. Okay, this is pretty good. Major problem is that we are drawing a free body diagram for the Earth. These people did a free body diagram for the Moon. Otherwise, this answer looks great. Okay, so for this one, first of all, they didn't answer the question about whether there's a normal force. And second of all, it looks like they've drawn the exact same force twice. There's only one interaction, which is the force due to gravity. And so we should not have this, and we should not have this. The direction's wrong because the direction of the arrows needs to align with the picture of the scenario. So they should be going left, right, not up, down. Okay, so I would agree that we've got Earth, Moon. This one, force is going in the wrong direction because, again, the free body diagram has to align with your picture. And then I'm not sure what balanced has to do with normal force. Normal force is whether or not things are in contact. Okay, they didn't show any interaction, and anytime you have 2 objects with mass, there is always going to be a force due to gravity in between them. So this is gravity. Any 2 objects with mass, force due to gravity. Sometimes we ignore it, but okay. So I would say there is an agreement, though, between what they had for their schema. They didn't put any forces on their force diagram, but this is correct. No normal force because objects are not touching. They forgot about weight. Okay, so no normal force. So we should not have 2 arrows, but I do like that they have them oriented correctly. And then if we look at the part 3, is there a normal force? I believe so, because if not, there would be no gap between the Earth and the Moon? I'm not sure I understand this because I think there is a gap between the Earth and the Moon. The atmosphere and a whole lot of space. So. Okay, so good system schema. Right force arrow, but wrong direction. Again, the direction needs to align with what your picture looks like. And then we've got gravity is the only force acting on the moon because it is the only thing keeping the moon in orbit. True. And we shouldn't say thing. Well, yeah, we can say thing. That's good. Okay, so the only issue I have with this is the direction is wrong. We're actually looking at the force on the Earth by the moon, and the moon is pulling the Earth towards it. Gravity is always a pull, so it's always an attractive force. Okay, so just a lot of kind of blah, 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 normal forces where the gravity pull. So there's no object labeled G because only objects can go in the bubbles. Okay, great answer, direction correct. There would be no normal force in this scenario because the Earth and the Moon are not close enough for their electrons to repel each other, so nice job. Okay, so again, the only issue we have is the direction should be going that way, but other than that, excellent job. Okay, question 9. Below is a person skiing on frictionless snow. Draw a system schema. Okay, so we've got, I'm going to draw kind of two options because some of you guys want to do this. So something that I should have mentioned is that anything attached to a person we assume is part of the person. It's not separate. And so the skis are attached to the skier. So we've got the skier. I'm going to do skier. We've got the ramp. And we've got the Earth. That's option 1. So there's a normal force between the skier and the ramp because they're touching each other. And then there is also gravitational force. So this is normal. This is gravity. And then the ramp does stay attached to the Earth because of, I guess we could call it a hill, not a ramp, whatever. So we can call this gravity as well. Some of you will just want two objects, which is fine. So we can have the skier, and then we can have Earth, ramp. Okay. And in that case, we've got two interactions because there are two different types. One is normal, one is gravity. Some of you, I feel like, are automatically drawing two lines between any object in the Earth, and that is not true. I have to have two different interactions. Okay, so we want to draw a free body diagram. Remember for the person, okay? So do the boundary. It doesn't matter which one we do the boundary on, we're going to get the same result. So there are two interactions, 1, 2. All right, dot is the person, not a huge circle, a dot. So this is the person. We're doing the interactions on the person. Gravity always goes straight down. We'll do this in a different color. So this is the weight. And this is the force due to gravity. And so the label is going to be the force on the skier by the Earth. Now, the normal force, we know we have a normal force. It is perpendicular to the surface, which means the normal force makes a right angle. So we need to think about what does a right angle look like? That is a right angle, okay? So that is the direction that the force goes. Whoa. Okay, it goes that direction. So that is the force on the skier by the ramp. Okay? And notice it's perpendicular to the ramp, and so it goes off at an angle. And this is it. Okay. Oh, I forgot to answer. Is there a normal force? Oh, yes, there's a normal force. The snow pushes up on the person skiing. So that is correct. Somehow, that's funny. I got that. Okay, so yes, there is a normal force because the person is in contact. So that's what we're looking for. Person is in contact, so correct. Snow and earth, we can accept that. And then the only thing that's wrong about this person is the angle. And so I'm going to redraw on top of it. So you'll see what I'm doing in a minute. Okay, so I'm gonna take this. Gravity always has to go straight down. And so if they had drawn it like this, that would have been perfect. Okay. Okay, so there should not be two interactions. There's only one, which is the normal force. Okay, only one interaction. Okay, so let's look at the labels, SP, PS. Those are Newton third law labels. Which never belong on a single force diagram. So we're looking at the forces acting on the person. And so anytime you have something where the person is not the first letter in the label, that means you have the wrong force, does not belong on the force diagram. So is there a normal force on the person? Yes, because the person is pushing down on the skis. You would have to finish that, and the skis are pushing back. Actually, I'm probably okay with just the red part. All right. And of course, this direction is wrong and, just the wrong force. Okay, I like this logic. Otherwise, the skier would fall through the earth. That's what a normal force does, is it prevents us from falling through things. So even though he doesn't say two objects are touching, I'm actually okay with that. Again, we have, actually, I'm okay with the labels. Let me make sure I was all right with the labels last time. Ooh, well, no, the labels cannot be correct because we're only looking at the forces acting on the skier. And so this one, the bottom one, is showing a force acting on the earth. We want the forces acting on the skier. So also, direction of this is wrong. Ooh, we've got weight, resistance. Wrong word. I think that they meant to say reaction. Again, labeling issues. We're only looking at the forces acting on the skier, so the top one is labeled incorrectly, and also heading in the wrong direction. Yes, this is a normal force. The snow and the skier are equal. Not a sufficient explanation. You have to have something about them touching. Okay, so I'm okay with this. The Earth, so we've got Earth and gravity. So Gravity is going to be the downward force, so I'm okay with that one, even though they did not do the label of force on the skier or person by the earth. But I don't know what this force is, and so we're going to get rid of it. Also, notice if we do our boundary, so let's do a boundary around the person, there's only 2 interactions, but on our free body diagram, we have 3 forces. We cannot have 3 forces. And so the upward force from the snow, this we're going to assume is the normal force. That is the correct force. Again, we're missing a label, but the direction is wrong. Hopefully you see a theme emerging. Okay. Okay. System schema. I'm assuming the K means skier, and so the skier has to be attracted to the earth by weight or force due to gravity. So we're missing that one. So normal force is earth that is pulling the person to the snow. Nope. Okay. That is, normal force is never a pull, always a push, and it's because 2 things are in contact. All right, now let's look at, I'm okay if this is the normal force. So we're going to assume that it corresponds to that interaction. I'm actually okay with that. It's not a free body diagram. Free body diagram has a dot and arrows off to the side. But that is definitely the wrong direction for weight. And so weight has to go down. Weight or gravity, it's the same thing. And then normal has to go perpendicular to the hill. Okay, so we are okay with the free body diagram, or with the system schema. Not okay with the free body diagram. Here's the person. Force on the person by the earth, so that one is correct. But the force on the person by the snow goes perpendicular to the hill. Force on the person by the snow goes perpendicular to the hill. So that force is wrong direction. Label's okay though. There's a normal force on the person because they are touching the snow. Good definition. That works for me. Okay, we're okay with the schema. All right, labels we have issues with. Wrong label. This should be on the person. First of all, we have P's and they should be F's, so that's also a problem. So force on the person by the earth should be the downward arrow. Wrong direction. Wrong label. So force on the person by the snow. It's normal force because the snow is pushing the person up while the person is being, we should say, pulled down by the earth. So, not quite elegant, but I'm okay. Elegant's the wrong word. Probably not quite accurate, but I can live with it for now. All right, so we're missing another interaction. We know that one of them is gravity, and then we also have to have a normal force. So normal, and then gravity. Force on the person by the earth, that is correct, but we are missing the normal force. Force on the person, again, we can say by the earth because they only have 2 objects and we can consider the earth as snow. There's no normal force on the person, but there is on the ski because the earth is giving the same force back. Okay, so this person thought the ski was a separate object, and so I'm okay with that. There actually is a normal force on the person from the ski, and so if you want to separate them into 2 objects, you can. So person touching the ski, normal force. Ski touching the earth, normal force. Finally, question 10. Okay, elephant stands on a ramp, system schema. So we've got the same ramp issue. So we've got elephant, I'm going to do EL. we've got earth, and I'm going to do earth and ramp in the same bubble. So we know that we've got weight or gravity, and then we've got normal force because they're touching each other. So free body diagram. The earth is going down. So this is the force on the elephant by the earth. And then again, we have to do a perpendicular. So I'm going to do a perpendicular line on my ramp. So that makes a right angle. And then I'm going to move it over to here. And this is the force on the elephant by the ramp. System schema, free body diagram, is there a normal force? Yes, because the ramp is touching the elephant, or the elephant is touching the ramp. Okay. All right, guess the most common mistake. Okay. So, good label, wrong direction. Okay, we've got no free body diagram because arrows on the diagram is not a free body diagram, and did not answer number 3. Okay, so again, if we look at the elephant and we just draw a boundary around it, there are 2 interactions. This person has 3, and the labels are incorrect. Force on the elephant by the earth, and then this one, wrong direction, should be going that way, or going up to the side, right? Force on the elephant by the ramp. And they didn't comment on number 3, is there a normal force? Okay, we got label issues. So that one says ramp. Okay, should be elephant. Direction of this is wrong. And again, I'm good with the logic. If there's no normal force, the elephant would fall through the ramp. So it has to be 1 because the elephant is resting on the ramp. Okay, I'm okay with the labels. Direction is wrong. Way too many forces here. Well, actually, I can live with those forces. Yes, the ramp is exerting a normal reaction force into the elephant, but you need to say why. You explain because they're touching. Okay, labels are wrong. Actually, that label's correct. This one, we need to have it be earth, okay? This free body diagram is about the elephant, and so the first letter of every force has to be elephant, because that's what it's about. And the direction is wrong. Elephant is pushing down on the ramp. Okay, I can live with that. They're touching each other. They can't push down without touching. Okay, that's good. Force of elephant. Again, what's pulling down is the earth. Person's missing the earth. So I know that they have weight to the ramp. It has to be weight to the earth. So earth, elephant is weight. Direction is wrong. Label's wrong. Yay, labels are good. Direction is wrong. Direction needs to go perpendicular, which is going to be that way. Did not answer number 3. Okay, arrow direction on the free body diagram is really important. The normal force is perpendicular to the point of contact. It does not always go up. All objects on the earth experience a downward force due to the interaction with the earth. This is weight. Objects must touch in order for there to be a normal force. Do not draw a line between two objects on the system schema unless you can identify the interaction. The number of lines between two objects must equal the number of unique interactions. And then also labels. So F, the first letter is feeler, second letter is dealer, and this is what the free body diagram is analyzing.